This is chapter 3, and it's a really important chapter about algebraic expressions. And we're going to talk about what an algebraic expression is. We're going to talk about adding and subtracting linear expressions. We're going to talk about the distributive property and factoring expressions. So there's four parts in this chapter. Not a long chapter, but a very important one. Now, for those who have skipped sixth grade math, there'll be some terms in here that you missed. Hopefully you got it over the summer when you were doing that. But we're going to review everything, and we'll take our time in this chapter. This is really an important foundation for how we do algebra. 3.1 is algebraic expressions, and I want to go over a couple of vocabulary words, and we'll talk more about these in this whole chapter, but and also we talked about them in class today. So in an algebraic expression, you have like terms that are terms that have the same variable raised to the same exponents. Now you also have something called constant terms. They're also like terms. And to identify terms and like terms in an expression, you need to first write the expression as a sum of its terms. So you got to be able to decide what are the terms and make sure they're all added together. Now, if you have something that is a subtraction, all you have to do is add the opposite, and then you can make it into an addition, and then you can figure out all your terms and then which ones are like and which ones are not. Okay, an algebraic expression, I should have started with this, is an expression with numbers, operations, and one or more variables. And a variable is just a letter of the alphabet that represents a number. So you don't have an algebraic expression if you don't have a variable. If you have all numbers and operations, it's called a numeric expression. Once you put a variable in there, now you have an algebraic, okay? And when you get an algebraic expression, you always want it in the simplest form, when it has no like terms and no parentheses. To combine the like terms that have variables, use the distributive property to add or subtract the coefficients. Okay, we'll get into that in just a second. Now, one other thing that's really important, there's a difference between an algebraic expression and an algebraic equation. An expression never has an equal sign. An equation always has an equal sign. So when you just have some numbers, variables, operations without the equal sign, you have an expression. That's what we're going to be dealing with in 3.1 and this whole chapter. Then when you have one that has equal, now you're dealing with an algebraic equation. And we'll deal with those later, but I just wanted you to know the difference between an expression and an equation. All right, let's get into this. Let's talk about identifying terms and like terms. So I have example 1 here. Let's look at A first. We'll do color red. And the first thing you want to do is you want to rewrite as the sum of terms. So right here you have 9x minus 2 plus 7 minus x. Now, the plus 7, that's good. But you have this minus 2 and this minus x. Okay, I want to change those into addition. And remember, the way we do it into addition is we add the opposite. So we'll change that and that. So now it's 9x plus negative 2. And you can see how they did that here. 9x plus negative 2 plus 7, that's already addition. And then plus, we do add the opposite. So add a negative x, and that's right here. So now we have plus, plus, plus. Everything that is separated by a plus is called a term. So 9x is a term, negative 2 is a term, 7 is a term, and negative x is a term. So in this one you have 4 terms. And in class we talked about a coefficient. Remember that a coefficient is a variable and a number that are multiplied together. Only terms that are separated by addition are actual terms. Okay. So now you want to put together, so here are the terms. So there's 4 terms. Now let's put together the like terms, the ones that are alike. They have to be either a constant, which means they don't have any variable. It's just the number. It can be positive, negative, it can be or any rational number. It's just a number. It's never going to change. It's constant. So in this one, we have 2 and 7. Those are my constants, and they're alike. Then we have numbers and variables, or a coefficient and a variable has to be the exact same variable. So if it's both x and x, then you have like terms. So this 9x is similar to just the x. So those are like terms too. I have these two as like terms and those two as like terms. So when we get to actually simplifying the expression, we can put those together. Okay. Let's do another example they have here. They have z squared plus 5z minus 3z squared plus z. Now I see there's only one subtraction, so I'm going to change that into add the opposite. So now I have z squared, 5z squared, negative 3z squared, and z. Now there's a lot of z's. But remember that like terms have to have the same variable and have the same exponent. So if they're the same variable without the same exponent, they're not like terms. So we have, we do have the adding. So now I know all my terms are 2 squared, 5z, or a z squared, I'm sorry about that, z squared, 5z, negative 3z squared, and just z. Now I find the ones that are like. And I see that z squared is not like 5z because it doesn't have the same, it has the same variable but not the same exponent. This has the exact same variable and exponent. So those two are like terms. And then I see also that 5z and z, they have the same variable. So those are like terms. Okay. Let's do some try-its here. So, and you can pause the video and try these and then come back and watch how I did them and see if you did them similar. So we have this first one here, which is y plus 10 minus 3 halves y. So I'm going to make everything into a addition. So I have y plus 10, okay, so I like that, that's an addition. Now the next one says minus 3 halves. So I'm going to change that to be plus the opposite, negative 3 halves y. So now I have all addition. Then I look at everything that's separated by that. We have the y, we have a 10, and we have a negative 3 halves y. So my terms, there are 3 of them. Terms are y, comma, 10, comma, negative 3 half y. Now, which ones are like? Well, I see this 10 is a constant. And are there any other constants? No, everything else has a variable. So like 10 is its own term, not like the other two. And then this one has a y, this one has a y with the same exponent. And so the other like terms would be y and negative 3 halves y. Those are like terms. Okay. Let's do number 2. First thing I want to do is I want to change it into where it's all addition. 2r squared plus 7r minus 2r squared. So I'm going to add the opposite. And then minus 9, add the opposite. So now I have 2r squared plus 7r plus negative r squared plus negative 9. Now, so I rewrote that. 2r squared plus 7r plus negative r squared plus negative 9. So my terms are 1, 2, 3, 4. Everything separated by an addition. 4 terms. Each one circled in red is a term. Now let's get the like terms. I see I have an r squared. There's just an r. There's another r squared. And there's just a 9. So I'm going to start with the 2r squared. So I've got that one done. Is there anyone else that has an r plus the same exponent? Yep, this one here. So negative r squared. Those two are like terms. So I got that one done. Now we have other terms. 7r. Does anything else have just the r as a variable? Nope. And then there's only one left. Negative 9. That's a constant, but also a term. So we have 4 terms. The like terms are right there. This one's like it's nothing else, and this one's like nothing else. So, all right. One more to go. We have 3 as a 7 plus 4b. 4p, sorry. Minus 5, which I'm going to make that into an addition, plus a negative 5. Then plus p plus 2q. So we have 7 plus 4p plus negative 5 plus p plus 2q. Okay. So I have my pluses. There's a plus, a plus, a plus, a plus. Everything on each side of the plus is a term. So I have a term 7, a term 4p, a term negative 5, a term p, and a term 2q. Now let's put like terms together. Let's start with the constants. This one right here, no variable. So it's a constant, 7. This one has a variable. This one has no variable. So negative 5, variable and variable. Okay, so 7 and negative 5 are like terms. Now let's do 4p. 4p, that has a p as a variable. Any other one have a p? Oh, yep, that one has a p. So 4p and p, those are like terms. And then we have 2q. So that one's doesn't have the p, and it's not a constant. So it would be 2q. Okay? So hopefully that helps you in really being able to identify how many terms you have, what are the terms, and what are the like terms and constants. All right, we're going to do another example here, simplifying algebraic expressions. And the way you simplify them is you could use the distributive property, which they show you here how to do that. I'm not going to really work on that a lot right now because we'll be doing distributive property later in this chapter and factoring out. But I want to show you how you can put like terms together. So let's move this up. Let's just do the triads. So if I have negative 10y plus 15y, so then I have this plus right there. So my terms would be a negative 10y and a 15y. Those both have y's, so they're like terms. So I can put them together, and it's just going to stay as a y. So negative 10 plus 15. What does that equal? Negative 10 plus 15, that would be a 5. And then the y sticks with it. So 5 times y. That is simplified. You can put these together because they're like terms. If you have 15 y's, you can put it with negative 10 y's, and you're left with just 5 y's. Okay, let's look at number 5. I have a minus here, so I'm going to change that, add it, and then make that negative. So I have a 3/8 b plus negative 3/4 b. Okay, so I have my adding here. So my two terms are 3/8 b, negative 3/4 b. And they're both the same variable with the same exponent. So these two are like terms. Now we can put them together. So I do 3/8 plus negative 3/4 equals. Well, remember when we add fractions, we have to have the same denominator. So that's going to be negative 6/8 instead of negative 3/4 because now they both have 8. So 3 plus negative 6 is a negative 3/8. Negative 3/8. And then you have to keep the variable with it. So there is your simplified. You can put those together. And the reason why you can put them together is because they are like terms. Let's do one last one, and then we'll be all set. All right, number 6. (2.4g minus 2.4g minus 9.8g). Well, I want to make these all addition. Plus negative, plus negative. Add the opposite. So now I have 2.4g plus negative 2.4g plus negative 9.8g. So I have my three terms, that, and they're all separated by addition. Now, this one is kind of not too bad because if I look at a 2.4g plus a negative 2.4g, what's 2.4 plus negative 2.4? If I have a positive 2.4 and I put it with a negative 2.4, I'm going to get 0. Okay, 0g. And 0 times g is always going to be 0. And so these two cancel each other out. And I'm left with this, negative 9.8g. And that is, once I put all of these together, that's what I get for a simplified expression. Okay? This is the beginning. Hopefully we have some idea. Some of this made sense. We will keep talking in class as we continue to learn about algebraic expressions.